Chapter 8 Prevalence of our covariant three-dimensional continuum over Einstein's four-dimensional form. In Einstein's hyperbolic theory of relativity, we have, for the square of the linear expression, ds squared equals negative dx squared minus dy squared minus dz squared plus c squared dt squared. This is the first example. This necessarily indicates a spherical shape for the space wave. At least that's how you mark it. The second member of the previous equality, which by the way can be equal to 0, that is, we can have dx squared equals 0. That is to say, dx squared equals ds squared equals dx squared plus dy squared plus dz squared equals c squared t squared. In this, as can be seen, ds squared is a three-dimensional function that depends on time as the only independent variable and is equivalent to the limit c squared of the speed of light in a medium or space of spherical contraction, because in truth the second member of equality from the first example is a simple function whose derivative limit is c squared. But c is the constant spherical radius for a fixed place in the universe, in the same way that g expresses it in all its circumstances of magnitude. The relationship d squared divided by dt squared equals s squared is therefore inescapable. It is that the genius, abandoning its theory of the hyperbolic type, perhaps believing that these curves are very wide open, proclaims that it's quasi-spherical and explains it practically by what is strictly spherical. This is absurd, since curves of different geometric species determine, as we have seen, incompatible spaces and relativities. On the other hand, this error, so large in itself, has not become noticeable in the applications of relativistic calculation, the perihelion current of Mercury, for example, because Einstein, without realizing it or knowing it, used the elliptical coefficient, which is, precisely as we maintain, a specific type of celestial concentrations. But insisting on the case at hand of the equation dx squared plus dy squared plus dz squared equals c squared dt squared, comes out dx squared divided by dt squared plus dy squared divided by dt squared plus dz squared divided by dt squared equals c squared, which, compared with the ds squared equals g ds squared of the previous chapter, or what is the same with the dx squared divided by g plus dy squared divided by g plus dz squared divided by g equals dx squared ds squared, or if you want, so that the formal similarity is more exact, and reducing the denominators to infinitesimals, the second member naturally will be limited like this. And then grouping, to make the comparison easier, the two qualities that concern us will be, by the second, it is understood that the speed s depends on the potential g convexity. This is form. In this virtue, two equations will be substituting in the second, and keeping in mind that in the first t is a function of the mass, as is g, since the equation in the first, given its structure, space depends on time, as in the second it depends on the potentials g of convexity. Take note that in this Einsteinian equation, time is used as a rest factor and not as the effect of a course caused by the medium. We observe this to point out a certain incompatibility in the use of t within Einstein's formula, Since for him time is the rhythm, the period, and now he uses it as required by the concept of the first equation, our own idea, as a static resting factor. In accordance with what has been said, we will then have that t and vg are variables of the same function, that is, of the same form of space. Then in the denominators there will be, when it comes to elliptical shapes, the following relations of equality. From this we deduce the identity of the proposed equations, and with it the prevalence of our three-dimensional covariant over the three-dimensional continuum used by Einstein. That is to say, dx squared plus dy squared plus dz squared equals dt squared c squared equals d blah blah blah. It is also clear that from the whole process that Einstein's spherical wave corresponding to his negative universe, or of the hyperbolic type, is nothing more than the analytical expression of the pure rectilinear in all directions within a positive space of the elliptical type. It's simply a three-dimensional continuum expressing a sphere located at its center within the covariant elliptical space, and nothing more.